Hello and welcome to another event of the Michigan State University Science Festival. I'm pleased that Dr. Jen Owen from the Michigan Bird Observatory is joining us tonight to talk about migratory birds. If you have any questions for Dr. Owen, you can type them in the chat if you're listening via the Zoom webinar. And if you're on Facebook Live, you can put your questions in the comment section. Thank you. And thank you, Dr. Owen, for joining us tonight.
Thank you, Roxanne, for having me. It's a pleasure. And I'm already going to say right up front, I have a dog that's barking in the background a little bit, so I apologize. All right. So I am going to be talking about migratory birds, and it is the right time of year to be doing it because this is when there's billions, approximately 3.5 billion that is, of birds that are returning from their wintering areas. And they're flying north for the breeding season. Now, over half of the 650 species of birds in North America are migratory. And these annual migrations are truly epic. And even studying them for over 26 years, I am still in awe of what they do and how they do it. Now, what is migration? Well, it's the seasonal movements of birds, in this case, from one geographic area to another, whether it's between summer and winter seasons they're moving, or if they're moving in relation to wet and dry seasons. But what this primary factor is driving the movement is birds are really trying to take advantage of seasonally abundant food. And some of those migrations are predictable and some of the migrations are unpredictable. Now, the migration that we're very familiar with is this latitudinal migration. And so what this graphic is depicting here, I find this an amazing graphic. This is by Cornell Lab of Ornithology, and it's based on citizen science data from eBird. Each one of those dots on there, it represents the average location for a species. And there's 118 species of migratory birds that are represented on this map. And you can follow them. So here we have December. Now in January, you'll start seeing some birds moving. As you get closer to March and April, the movement, the pace is very fast. They're moving up into the northern regions, up into the boreal region, and you'll notice that they don't stay very long in that boreal region, and they start heading back south. And in fact, they're really timing that for that seasonally abundant food. We can think of all the insects and mosquitoes that are around in the summer and spring. Now, what we take for granted about bird migration, we know that birds are doing it. We see the seasonal patterns of birds that are here for the winter, and then there's birds that are here in the summer and then gone in the winter. But before the 19th century, there were a lot of myths about where birds went during the winter. And in fact, Aristotle, who was probably the first person to really begin the history of bird migration studies. And so that started with him in 350 BC. And in his Historia Animalia, he references about 140 species of birds. And he was aware that birds migrated. But he was responsible for several myths about bird migration. One of those was the theory of transmutation, in which species like this common redstart, a common breeding bird in Greece, so it's there in the summer. So his theory was that it transmutated into this robin. This is a European robin. Now, this European robin was there in this winter in Greece, but the common redstart was not. Well, now we know those aren't the same species. Those are two different species, but they're similarly sized and they're closely related. And he even claimed that he saw birds in the halfway stage. Well, we now know what that was likely. He was seeing birds in molting when they're replacing their old feathers with the new feathers. Now, this transmutation theory died out fairly quickly. The second myth that he had about bird migration was about birds hibernating during the winter months. It took, believe it or not, 2,000 years for that theory to fizzle out. So he was saying that birds would migrate because you don't see them, so they must be hibernating somewhere. And then in 1555, Olaus Magnus wrote about how birds, swallows particularly, must be hibernating in the bottom of lakes in the mud, because they would have each, as this one drawing shows you, is fishermen were pulling up the nets and having birds and fish in these nets. Now, believe it or not, it wasn't until 1854 that the Swedish Academy of Sciences ruled that birds do in fact not hibernate at the bottom of lakes, and it's actually physiologically not possible. Now, another myth, this was by Charles Morton, an English minister and scientist who in the 17th century wrote a very surprisingly well-reasoned, although inaccurate, treatise about how birds migrated to the moon and back. And so he, as he said, where else would they go if it were not to the moon? Now, he thought about this so much, he even estimated the distance it would take. It was going to be 179,712 miles. It was going to take 60 days, one flight, one way, and the birds would be flying at 125 miles per hour. So all of that's pretty much not true, except that he got the distance to the moon actually fairly close, which is ranges from 226,000 to 252,000 miles away. Now, okay, so birds don't fly to the moon and back, but there is a reason why he might have thought this, and I'm going to come back to that in just a few slides. But birds do make some epic journeys. And in fact, this Arctic tern, over its average lifespan of 30 years, can actually travel the equivalent of 3 trips to the moon and back. It makes the longest migration of any species on Earth. And what we thought was probably like 26,000 miles round trip, and that seemed amazing. Now we know with technology and being able to have transmitters on these birds, that they're flying actually on average of 43,000 miles round trip. The bar-tailed Godwit, a shorebird. This bird is known for flying 7,000 miles over 8 days of nonstop flight. The Blackpool Warbler. So this bird is about the size of a chickadee. It's 12 grams. That's the equivalent of 2 quarters. And it also makes a pretty epic journey. In the fall, it'll actually depart from the Gulf of Maine, and it can fly up to 86 hours nonstop. Now, it can't just do that without actually eating a lot of food. So before it departs, these birds over a couple-week period will eat at a very high rate, to the point that they're just gushy with fat, and they can double their body mass within that 2-week period. And I should point out that there's far more birds that make these really incredible journeys. I mean, you can think about a ruby-throated hummingbird that makes a long migration. And as they're making these migrations, they need to find food in order to fuel those flights, which I'm not going to talk about here much, but just wanted to make sure to point out how important food is for migratory birds. Now, one of the questions we get a lot is, well, how high can birds fly during migration? Well, most of the year, birds are just going to fly around 500 feet or less. But when they're migrating, they are flying at much higher altitudes. And how high they fly depends on a variety of factors: body size, wing morphology, whether they're flying over land or water, the wind and weather conditions. Now, the true epic flyers in terms of altitude are these barheaded geese. And here what I'm showing is you have the barheaded geese. Let's see if I can see my pointer, but that you think of peak of Mount Everest. It's almost 30,000 feet. And the barheaded geese can actually fly at a cruising altitude, or known to fly at a cruising altitude of 29,500 feet. So pretty incredible heights. Eagles and vultures and geese typically are in the 20,000, 25,000, and a lot of shorebirds are around 20,000. But then most of the other migratory species, including songbirds, are migrating between 10 to 15,000 feet, with some of the birds like robins and crows, swifts and swallows migrating at lower between 3,000 to 4,000 feet. Now, when we think of bird migration, we think about these geese probably, right? So this V-shaped pattern of geese as they're flying, sort of the classic sign of bird migration. Or around here, you might be thinking about the sound of the sandhill cranes as they're arriving in late February, early March, or departing in the October. Now, those are the birds you can see in the day, but most of the migration, in terms of songbirds, is happening at night. And so this painting by Charlie Harper, the 1990 Mystery of the Missing Migrants, is depicting these birds that are flying at night that we don't get to see. However, if you were to go out, and this is the time of year, right? So birds are going to start coming, migrating fairly soon. We're going to start seeing a real pick up in bird movement. And it's a clear night. And I don't know if you can hear this. You'll hear some call in the back. But this is showing you, if you were to go out and look at the moon with a telescope, or even sometimes binoculars, you might see the silhouette of birds as they fly across the moon's light. And so this, and also if you go out and it's very quiet, you don't have a lot of other noise, you might be able to hear their flight calls because they make unique flight calls. It's contact calls while they're flying. They're not flying all together. They're not flying, as groups necessarily, but they are making contact with one another through these calls. So this is probably why, in some ways, Charles Morton thought that birds did migrate, to the moon and back. Now, when do birds migrate? So what's a night look like? Well, they depart, so about 30 minutes after sunset. So they usually go through this very quiet period, and then they'll start to kind of move up to the tops of the trees, and then they'll take off. And they'll typically fly until maybe 2 a.m. It's going to vary quite a bit, but the peak time of movement is between 11 p.m. and 1 a.m. Now, the question you might be asking is, well, how do the birds know when and where to go on this migration? So who are they following? Do they follow their parents? What tells them it's time to go? Well, actually, a lot of migration is innately programmed. That is that the birds are born knowing the direction and distance they need to go on their first migration. And so this indigo bunting that's pictured here, the red is its breeding areas and blue is the wintering areas. And it makes a fairly predictable migration, departing its breeding areas around the same time every year and arriving. It varies quite a little bit, and that's a whole nother talk. And so when they do this, their first migration, they actually do just fly to the wintering area. And again, they're born knowing that. And how do we know that? Well, because of birds being held in captivity, not for research purposes. So it's actually in the 19th century. So you probably see this in movies where people really want that lovely nightingale that's making that beautiful song, and they have the bird in the cage. Well, these bird fanciers that had these birds, they would start to notice that at night the birds were actually being very restless, and they're showing a lot of activity in the cages at certain times of the year. And what they found is actually, and this was first published in 1707, that birds were showing this very seasonal restless behavior called zugaru. And that activity in the cage actually corresponds with the distance and the circadian rhythm of that bird's migration. And even beyond that, so we know that birds, so you can put them in a cage and they're going to show activity consistent with migration. Also, on top of that, if you were to then place them into sort of a funnel, so like it's showing here, so these sparrows are in these funnels and they have access to the sky, so they're outdoors. They found that not only were they show this restless behavior, but it was directional. that they would actually hop in the direction they were supposed to be going. So if it was fall, they would hop in the southerly direction. And if it was spring, they would hop in the northerly direction. And this really became well studied by Steve Emlen with these what are called Emlen funnels. And what you can see here is that in the middle of this sort of cone is, well, I don't know if you can tell, but it's an ink pad in the middle. And so the bird might be on that in the middle. And so they have a little bit of ink on their feet, like a stamp pad. And then as they hop, they then leave a mark on the paper that's surrounding that sort of cone. And so they would do this at different times of the year during fall and spring migration. And sure enough, the birds did. They hopped in those seasonally appropriate directions, as you can see here with the spring. So all of the ink, right, in showing spring is pointing, towards the north. In the fall, it's pointing towards the south. Now, how do they know the direction? I mean, so how do they know where they are and where they're going? I mean, they're born knowing the direction they need to go, but how do they figure that out? I mean, they don't have Siri telling them what to do. They don't have the GPS unit per se on their dashboard telling them this is the way down south. So birds have, and I wish I could go into all of the different types of ways they know this, but they have multiple compasses. Because you don't want to rely on just one, you want to have several. And those include the Earth's magnetic field, a really important compass for orientation. So this is what orients the bird in the correct direction. They use the the sun. Where does the sun set? Polarized patterns of the sun. And they also use the stars. And that's what I wanted to just share with you tonight, is to talk a little bit about the star compass. Because in previous Science Fest, we've been able to actually show you this in the planetarium, where to show you kind of how these experiments actually occurred, how scientists discovered how birds use the star compass. Now, the question really is sort of like, so we know they use stars, so I should point that out first. So there are some really nice experiments that showed that birds are clearly using a star compass, because if you had them in those orientation or those sort of cones, the Emlen funnel, and you had them in a planetarium and you showed them stars, the normal sky, and then you had no stars, right? No constellations. The birds didn't migrate. So they did migrate when they could see the stars. So they knew that they did that. But the question is what is it about the stars that tells them where to go, the direction they're heading? Are they born knowing the stars? Are they born knowing the pattern of constellations? Well, they didn't know. One thought was that they actually maybe memorize. They are born knowing exactly where the constellations were. But can you imagine? The constellations are in a different part of the sky throughout a night and also seasonally. But there is one constant, and that's the Polaris, the North Star. So the North Star, the Polaris, right, is that no matter where you're standing, right? If you're out, the Polaris is always in the northerly direction. And it is fixed, essentially, barely moving. And the other stars essentially are circling around it. So I'm going to click. So, right, so if you've done star, I forget what they're called, star circles or star trails. So that's, you can see that, right? You can see where the Polaris is, and you can see the fact that the stars are moving around this. So the course of the night, the Polaris doesn't rise or set, and it's also in the same spot pretty much year round. So it's a pretty good landmark per se, a sky mark. So the question is, are they born knowing that Polaris is the North Star, that it's actually Polaris? Because in, I don't know if it's 12,000 years or so, it's no longer going to be the North Star. Well, they needed to figure this out. And so they did this set of experiments. And I thought this was really neat, especially for Michigan, because Steve Emlin did these experiments actually in the Robert Longway Planetarium in Flint, Michigan. And so what this picture is showing you is sort of the scaffolding where he had these orientation cages. You can see them sort of on the shelf at the top there. Let's see if I can, right up in here. And so these birds, and he was using indigo buntings. So that bird I showed you earlier, a nice beautiful blue male there. And he raised them in the planetarium. And he had them raised under different conditions. So envision here, you have 3 different sort of experiments. You have birds that are raised under the normal sky. So in a planetarium, right, if you haven't been there, you go in and it's this beautiful dome and you can look up and you can see what the constellations look like, right? And you can see how they move naturally. I mean, they simulate that in the planetarium. Then he also had the birds with no stars. And then he had the stars, the constellations. He then kind of manipulated the planetarium and made, instead of Polaris the fixed point, he made Betelgeuse the fixed point, stationary. Now, first, when they were doing these types of experiments, they found that birds weren't really actually behaving normally. But they found out, interestingly enough, if you play cricket sounds, you know, that sound you hear at night, then the birds would actually, that was better to have them dead silence. Then they were able to show more appropriate behavior. And so what he found was in these experiments that they were all raised with these different skies. But then when they were then after that placed with just the normal sky. So at this point, these birds are placed with just a normal sky. The birds that were raised with the normal sky, where Polaris is the fixed point, they oriented in the correct direction. But the birds that were raised with Betelgeuse as the fixed point and then exposed to the normal sky they weren't able to orient in the correct direction. So it's not that they were born knowing all the constellations and born knowing that Polaris is the North Star. It's that they had the innate knowledge that the fixed star was north and that the constellations are moving around it. And then using that, they learned the sky. So on these first migrations is when birds are very dependent on these cues, these star cues. And as they ate on their subsequent migrations, then they use more navigational cues. They use experience to find their way. And as I said before, the birds use multiple compasses. Magnetic compass is really an important compass. I don't have time to talk to you about it today. And they have multiple compasses. Can you imagine on a cloudy night, right? How would birds find their way? Not all birds migrate at night, so the star compass is not going to help all birds. Like swallows and swifts, they typically migrate in the day. So again, different ways that birds orient. And so this is just a few of sort of the, I think, amazing things about birds and a little bit about how scientists have figured some of this stuff out. So I'm going to finish with that and just thank you all for your attention. And I'm happy to take any questions. We do have a Migratory Bird Observatory where we, in non-COVID years, have open to the public to see migratory birds in hand. We are going to be doing some virtual events this spring. So if you're interested, definitely reach out to us. We'd love to share our love of birds with everybody. So thank you. And I'm happy to take questions. I'm not sure how that works. So.
I can ask the questions for you. We do have a couple. Jack wants to know, do the birds use star orientation to know when it's time to migrate?
Great question. And I forgot to mention that. So birds vary. So birds that are obligate migrants, like the indigo bunting, I apologize for the dog, they actually migrate at the same time each year, and they use photoperiod. So actually in captivity, you can actually make a bird or sort of induce them to migrate by changing the day length. So in spring, you can just make the days longer. And that is what they use as a cue to actually leave. And so, yeah, photoperiod is a big driving factor for obligate migrants.
And then Elizabeth has a question. How does climate change affect bird migration?
Quite a bit. We're clearly learning more and more about that. So one of the things we're finding is the phenology is being altered. And it's not just the phenology of the bird, so the timing of when they move, because some of that is temperature. So you have that primary cue of photoperiod, but that can be modulated a bit by temperature. And what we're seeing is that one, there's a mismatch sometimes between when food is available, the insect abundance, and when birds are migrating. And sometimes they're mismatched that they arrive before there's really a lot of food, and birds are doing what's called the reverse migration and having to fly south, further south again, which is a huge energetic cost. So there's lots of ways that it's affecting, and a lot of it we're still learning about too with these long-term studies. Great question.
And then Erica has a question. Any sources you recommend for more on these topics?
Oh, yeah. So I would say that's a good question. In terms of websites, or I mean, there's great. The Cornell Lab of Ornithology always has great information on their website. Audubon also has really great, either at your state or national Audubon websites have also really great information. There's also some good books I'm happy to share as well. And then if you were in the area and you wanted to learn more, we also do a lot of that with our migratory bird banding station, is talk about bird migration.
Awesome. Another question from Ang. When do Baltimore orioles, hummingbirds, and rose-breasted grosbeaks migrate to Michigan?
Well, it's gonna be soon. Certainly those Baltimore orioles, I don't know if people start to see them. I was actually just looking at my list of when I see birds, but we're talking in early May, we'll start to see them. Peak migration around here for a lot of the warblers and stuff is really second to third week of May, I would say, are some of the best weeks for bird migration. Hummingbirds of those three species are last, but I would start looking out for them in end of April, early May.
Awesome. I know I keep waiting for the birds to show up. Every day I go out and see if anybody new is at my feeder.
That's right. I know. We're definitely birders are out there just seeing what are the birds that are out there now. So right now we have kinglets, ruby crowned and golden crowned kinglets, which are some of the earliest migrants. They migrate pretty far north.
Awesome. I had a question going back a little bit. So you were talking about songbirds when they take off like between 7 and 11 p.m. and they do calls. Do they call only to their own species, or do they sort of talk to each other, species to species?
So I don't know necessarily all of the sort of communication, but what we think is it's just like they're loose. So let's just say in the fall, birds are making what we call a broad front migration. They're not necessarily funneling in certain areas. And there's these large, loose kind of flocks. And it's just maintaining sort of maybe knowledge that there's, where birds are, say altitude or so forth. And every bird species has a unique flight call. So actually they record them. And if you know those, you can actually identify the species when you hear those calls at night. So they're not necessarily, it's not just to their species, it's more because birds are not migrating in species specific flocks, they're migrating in mixed flocks. Yeah.
Awesome, I wondered. Well, it looks like we are out of time, except I just had one more comment or question from Jack. He says, hummingbirds have been sighted in Michigan already this year.
Okay.
So there you go. I guess I got to get my hummingbird feeder out there.
Great. And I should have said that too, is that, every year this is, even though there's like sort of this predictable pattern with migration, it's always an unknown, right? Every year is different in terms of, right? Because the phenology, the weather, the insects, everything's different each year. And so it's fun. It's fun. You never know when you're going to see a bird come through.
It is exciting to see those first birds that come your way for a little bit.
Yeah, it certainly is.
All right. Well, thank you, Jen, for this wonderful talk on migratory birds. And I will mention that the Science Festival continues on through April 30th. Tomorrow is our statewide astronomy night. So we have planetariums across the state that are going to give talks and demonstrations starting, I believe, at 4:30 tomorrow. And then followed on Saturday by our Expo Day, where we have 40 or 50 talks. And you can find out all the information on our website, sciencefestival.msu.edu. And thank you again, Jen, for a wonderful talk.
Thank you so much, Roxanne. Thank you, everybody. Have a good night.
Good night.